Hi, my name is Thomas Davies.
And I'm Emily.
And we are first years in engineering at Queen's University.
And we're on QSET.
Hey, I'm Will. I'm in mechanical engineering.
I'm Sydney. I'm in my fourth year geological engineering. And we're both on QSET for our first year.
QSET's taught me a lot about working as a team on a large project, especially trying to cross-reference between teams as I'm on mech and trying to communicate with people on the elect team. It's been really useful in kind of knowing how large projects can be managed.
Building things, I got to learn how to use AutoCAD and just how transferring things from a design to actually building it can be more difficult than you think.
We're not really involved in any of the technical aspects. We're more in QSET for learning experience to better equip us for other years. So in second year, we'll be able to help more with the design and things. But in first year, we worked with another upper year within the club who helped us using Arduino and motor controllers.
We did a couple simple tasks on Arduino, like work with motor controllers, potentiometers, servos, buttons. We definitely made a button.
Yeah.
And it turns an LED on and off, so.
QSET's been able to get me involved in an industry that I'm interested in working in after school. I'm really interested in working with MDA, and it was nice being a part of QSET and being able to meet some people who work in the industry from MDA specifically, and just kind of knowing how our project of the lunar rover kind of goes over into the real world and how they kind of relate.
It's really given me the chance to explore something I'm interested in, which is space industry. The space conference that they put on a couple months ago was really interesting. And it's something that I haven't been able to explore previously with my geological engineering degree.
QSET has really let me build connections with upper years that I wouldn't have been able to build if I had not been a part of the club. So I feel like that's a good benefit for me because it helped me choose how much discipline I wanted to go into.
I was going to go into chemical engineering until I joined QSET, and now I'm going to electrical second year, so. Yeah,
same thing with me. Originally when I came to Queen's, I wanted to go into mech, but then through my learning and the good times on QSET, I ended up going into electrical.
I've had a lot of fun after joining QSET. I mean, the main reason I joined it was just have fun, to do something different than my normal day-to-day, go to school, do work. And there's been some socials, which have been a lot of fun, but mainly just coming to the meetings and working on our project.
In the next few years, we plan on continuing being members of QSET and applying the knowledge that we learned in first year.
Hi, I'm Robert. I'm the electrical manager for Queen's Space Engineering Team. I just wanted to give you guys a quick update on what we've been up to since the last update. So currently it's halfway through March, and we're looking to go for our competition. It's going to be in 2 months. Currently our mechanical prototype is done, and we're working on implementing all of the major electrical features. So we've got our wireless communication working for basic motor control. We can turn all our motors on and off. We can make them go forward and backward and at variable speeds. We have our actuators moving up and down, and we have our conveyor belt working at a basic level. So we have a really cool user interface. So what happens is our robot is controlled remotely over a wireless connection. So we sit in a base station room, and then the robot is teleoperated. So we've created a really good user interface using a PS3 style joystick. So basically controlling the joysticks controls the left side and right side of the motor respectively. So pushing the left stick forward will drive our left motors, the right stick will drive our right motors. This will allow for differential drive, so which we think is the best way of piloting our robot around. The various buttons on the controller will control the other aspects, including moving the actuators up and down, telling the conveyor belt to turn on and off, and telling the robot to enter autonomous mode for when we finally get that going. We've started looking into autonomy as well. Basic autonomous operation is going to be achieved using an Xbox Kinect system. We want to be able to survey the playing fields, get a good 3D mapping of where we are, and then using our onboard laptop, mapping a path to navigate the playing field, and then autonomously load itself and then go back to the bucket and unload. Currently, our progress on this we're just getting started in this area, but with 2 months to go, we think we should be able to achieve it by the competition time. Right now, all we have to do is we have to continue to work on integrating our power system, getting our electrical box finished and mounted onto the robot, and from there, just doing a lot of testing to make sure the robot works the way we want it to. Obviously, the competition is in about 2 months, but we think we're moving forward to have the robot done on time and be able to compete in the competition.
Yeah, Mech's doing really well this time. We're basically at the end stage right now. We're just putting the finishing touches to the final design, and we're just about to start doing testing. We're doing some corrections to the scraper, which is on the frame. We're printing the wheels, which are really, really cool. They're really interesting. We have like built-in gears and stuff in them, so it's being super, super easy thanks to the fact that we're able to 3D print them through this company. The conveyor is just waiting for the chains still. They should be soon. We're working on all the stuff. Everything else is in. It's just the chains. That's all that's left. The scraper's looking good. We're just modifying it to make sure that it's going to be strong enough to do all the picking up, the material, all the digging. The design is actually looking really good. Like, we don't have that much left to do. Everything looks really real this year. Like, everything's actually hardcore. Like, we're going to be a legit contender for the competition this year. Like, the mechanical design is very solid. It'll be really good for next year too, because we're going to have a really solid design from this year that next year's students will be able to look at and kind of get an idea of what is the kind of things that's possible to do with the materials we have. Because, for example, like the aluminum extrusion we're using, the T-started aluminum extrusion, is really easy to work with and makes designing stuff so much easier. And you can modify it really easily. You don't have to drill. It'll be like reusable for next year. Like, there's tons of benefits for it. So that was a good pickup and will help next year a lot.
Basically, as first years, because we don't have a big enough stop. I can't see you.
Oh God! That's funny.
Call Emily. Okay, stop it.
Yeah.
Oh, thanks.
Can you just like edit her out?
Ew, why just stop?
And we are on QSET.
QSET.
Q!